Hi guys, it's Mrs. Millison again. I'm going to go over the answers to the Check Your Understanding on page 32 to 33. Okay, we're going to look at back-to-back stem plots and write a few sentences comparing the number of pairs of shoes owned by males and females. Okay, anytime you're asked to compare a distribution, you have to sock it and then compare. Who's greater, who's less, where are they the same, where are they different, and things like that. So let's come up and look at the male and female information. Okay, so here's a back-to-back stem plot of the number of pairs of shoes that male and female students have at a specific school. First, we have to understand how to read the numbers. So if I look at 3, 5, that means 35 pairs of shoes. Over here, it's 3, 8, so this is 38 pairs of shoes, okay? First thing we're going to do is talk about the shape. All right, for the males on this side, from low to high, you can see the peak, and it's definitely right skewed. Now, for females, it's going to go from low to high, so it's kind of like you're looking at it upside down. Now, it appears to have a mode there and then another mode. So this appears to be bimodal, but still probably left skewed. Oh, excuse me, right skewed, okay? So whereas this one is definitely right skewed and unimodal, this one appears to be bimodal, but still right skewed, okay? Center. I believe there are 20 observations. Yeah, there's 20 observations for female and 20 observations for male. So again, if we go 10 in from the bottom and 10 in from the top, there's no middle value. So we've got to look at the 10th and the 11th. So we got to, count from the lower one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So if I average 26 and 26, I'm going to get 26. So the typical number of pairs of shoes that a female has is 26 pairs. And then the males, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's going to be between 8 and 10 pairs. So roughly 9 pairs is the typical number of pairs of shoes a male has. So we can say that the typical number of pairs of shoes that a female has, 26, is greater than or more than the typical number of pairs of shoes that the males have. Okay? So that's center. Spread, again, high to low or low to high. The female number of pairs of shoes, range from 13 to 57. Okay, so from 13 to 57. So what's 57 minus 13? So 44 is the range. Okay, males range from 4 to 38. So from 4 to 38, that's a 34 pair of shoe range. So we can say that the spread of the female spread for the typical number of pairs of shoes is larger than the spread of the male number of shoes. Okay. Outliers. So let's look at males. So this appears to be the bulk of the data. So 35 and 38 could be potential outliers. Maybe 22. I don't know. Okay. But again, we'll quantify outliers coming up. Now, females, since we have 2 modes here, since this is the first peak and this is the second peak, there really doesn't appear to be any outliers. Now, if that wasn't a mode, if it was just 907 over here, we could say that those could be potential outliers, but since there's more data over here, I don't really think we could say there's any potential outliers. But again, we'll quantify that in the next section. Okay. All right, let's come over and do the rest of this Check Your Understanding up here. And then we'll finish this one. Zoom out a little bit so you can see that too. Okay, so here we are, some multiple choice. We're going to look at a stem plot of the percents of residents age 65 and older in the 50 states and the District of Columbia. The stems are whole percents and the leaves are tenths of a percent. Okay, so there's percent of residents that are older than 65. So if we look at our key, like 16/8, that means 16.8% of residents are 65 and older. Now, I have no idea which state any of these numbers correspond to, but whatever. Okay, the low outlier is Alaska. So low outlier, these are my low numbers, these are my high numbers. So this must be the low outlier. So what percent of Alaska residents are 65 or older? So again, this is just reading the key. So 6/8 is 6.8%. So that would be B, okay? Ignoring the outlier, the shape of the distribution is what? So if we ignore this outlier, and I kind of trace my hand along the distribution here, trace my finger, it seems to be roughly symmetrical. There's no big tail on the high end, so I would think it was right skewed. There's no really large tail on the low end, so I don't think it's left skewed. So I'm going to say roughly symmetric, okay? And the center of the distribution. Okay, so putting the outlier back, there's 50 states and District of Columbia, so that's 51 pieces of data. So if we count in 25 from each side, the 26th observation will be the true center. So it doesn't matter which way we count in from. I'm only going to count in from one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So it's 12/8, which is 12.8%. So that's the center of our distribution. Okay, thanks a lot, and I'll see you the next time.